Well, this is M1, January 22. First question is a particle P of weight 5 Newton is attached to one end of the light inextensible string. The other end of the string is attached to a fixed point O. The particle P is held in equilibrium by force of magnitude F newtons. The direction of this force is perpendicular to the string and OP makes an angle 60 degrees with the vertical, as shown in figure 1. Find the value of F, and the second part is find the tension in the string. Find the value of F and the tension in the string. Now, there are three forces. Weight is given. The weight is 5 newtons. The weight is 5 newtons. Vertically downwards. Let the tension in the string be T newtons. The angle is 90 degrees. So there are three forces and equilibrium. So whenever there are three forces in equilibrium, you can apply the Lami's theorem. So A part is, as there are three forces uh, in equilibrium, so using the Lami's theorem. So we can use the Lami's theorem. So for the Lami's theorem, we need to know the angle between different forces. So for two of the forces, F and T, the angle is given as 90 degree, but the other two angles are not mentioned there. So you can you can use this basic mathematics. So we have a right angle triangle. For this right angle triangle on the left hand side, one angle is 90, 60. So this angle is 30 degrees. In this way, you can find the total angle from T to between T and 5. So this angle is 90 plus 30, 120 degrees. This is 90 degrees. So this angle, which is angle between F and 5, by adding 120 and 90 and subtracting from 360, this angle is 150 degrees. In this way, you can find the angle between different forces. So there are three forces, equilibrium, you can using the Lami's theorem. So Lami's theorem states that if there are three forces, so force over sine of the angle between the other two forces, force, say F over sine of the angle between the other two forces, which is 120 between T and 5, is equals to 5 is the known force over sine of the angle between, if 5 we are writing in the numerator, the other two forces are T and F, and angle between them is 90 degrees, so 90 degrees. So in this way, F you can find just in one step, 5 over sine of 90. Sine of 90 is 1. So multiply by 120, sine of 120. So F in this way you can find in the exact form or in decimals, 5 sine of 120. I'm calculating it. This is 5 square root of 3 upon 2 newtons, or if you write in decimals, this is 4.33 newtons, or you can write 4.3 newtons, correct to one decimal or two significant figures. So we have the value of F. After F, so this is the Lami's theorem. Again, by Lami's theorem, again by Lami's theorem, again by Lami's theorem. This is the working for a second part. B, this was part A. So F is there. Next is find T. T over sine of the angle between other two forces. If T we are writing, then other two forces are F and 5. So angle between them is 150. So T over sine of the angle between the other two forces equals 150 is equals to the known force, which is 5 over sine of the angle between the other two forces, which is F and T. So in this way, we have T value is equals to 5 over sine of 90. We know it's 1 multiplied by sine 150 degrees. When I simplify using calculator, this answer is coming as T is equals to 5 sine of 150. You can again find this answer in exact form. This is 2.5 or 5 over 2 newtons. In this way, you can find the answers by using the Lami's theorem. Very simple. So this is one technique for this is one method. There are two more methods. The other method can be like if there are three forces in equilibrium, you can always draw a closed figure because there is no resultant. So, or I can write method number 2. So for this method, what I'll do, so we have three forces. One force was here, which is F newtons. The second force was here, which is at 90 degrees, and T newtons. We mark this as T newtons, and this was 5. So angle between, and this angle was 30 degrees. So as equilibrium, there is no resultant. You can always draw a closed polygon for such cases. So as there are three forces, starting with any force, like if I start with T or 5 or any force. So let us start with F Newton's force. So F Newton force is here. So I'm just drawing F force here. This is F Newtons. So the other is the force which is vertically downwards. And keep in mind that the angle between T and F is 90 degrees. So this is an order head to tail rule I'm using here. So I must draw the last force which is here. This angle is 90 degrees because angle between the forces is 90 degrees. So I can draw. So this angle is 90 degrees, and yes, I can complete figure like this as there is no resultant. So for the no resultant, the head of the last should be joined with the tail of the first. So we have this angle as 90 degrees. Angle between F and T is 90. Yes, this was 90 degrees. And T is in this direction, F is, and vertically downward was 5 newtons. Furthermore, how to adjust the 30 here? 30 is the angle which T is making with the horizontal. So I can draw the horizontal line here, and this angle is 30. If this angle is 30, obviously this was vertical, horizontal, vertical. So this angle is eventually 60 degrees. So in this way, there is a triangle, a right angle triangle. For the right angle triangle, we have one angle 90 degrees, the other angle is 60 degrees, and you can apply the trigonometric ratios. Yes, we have P. So you carefully draw this. So 5 newtons is here, which is the hypotenuse. One is the base or and perpendicular or opposite and adjacent. So any concept you can apply here. So right angle triangle. So question was to find F and T. So we have a closed polygon. I drew these three forces, and the last I started with F and then 5 and then T. T head is joined with the tail of the first. So we have a right angle triangle. So keeping in mind the angles 30 and 60 and how to relate 90 to this figure, we have a triangle. So for this triangle, you can apply the trigonometric ratios, uh, sine, cos, or tan. Using opposite or adjacent and hypotenuse. So we have here let us find f. A part was to find f. F is opposite. F over 5 is sine 60, and f is equals to 5 sine of 60. This is 5, same as before. 5 sine of 60, 5 root 3. So f is 5 root 3 square root 3 over 2. So this is the answer, the value of f. Also, you can apply t is the adjacent. So t over 5 adjacent over hypotenuse for the right angle triangle. It is cos of 60 again. So t is equals to 5 cos of 60, and t is equals to 5 over 2 newtons. The same answer this time. So the first I applied the Lami's theorem, and next I use the concept that there are three forces in equilibrium. You can always draw closed polygon as there are three forces. This polygon is a triangle and one of the angle is 90 degree. So luckily there is a right angle triangle, so you can easily find f and t by using the trigonometric ratio for the right angle triangle. So this was method number 2. There is another technique, another method, the third. So let me start it from here. So method number 3. So method number 3, in method number 3, what I can do, I can resolve the given situation into components like, for your convenience, I can write here. This force was F. This force was T. Here was 5 newtons. This angle was marked as 90 degrees. And from above working, I can draw horizontal line, and yes, from the above, this angle, this was 30, and if this angle is 30, on the right hand side, 90 plus 30 is 120 subtracted, so this angle is coming as 60 degrees. So after this, uh, after marking the angles here, what I can do, I can resolve the forces into the components. So in this case, I can resolve forces horizontally and vertically. Yes, horizontally. So F, so 5 is already vertically, you don't need to resolve. So F is rightward, so head to tail rule. This is F cos of 60. This is F sine of 60. Same way, T force left and up. So here, this was T newtons here. So I can resolve into the components. So relative 30, this is T cos of 30. This is T sine of 30. So as equilibrium, so resultant is 0, leftward, rightward, leftward equals to the rightward, and upward, sum of upward forces equal to the sum of downward forces. So I must write it here, resolving the given forces horizontally and vertically, which I've done there. Now, next is simple equating horizontally what is happening. F cos 60 is equals to T cos of 30. Okay, number 1. And F sine 60 upward plus T sine 30 is equals to sum of upward equals to the downward, which is 5 only. So question for solving them simultaneously. What I can do from 1. So from 1, making t the subject, t is equals to f cos 60 over f cos 60 over so right word is f cos f cos is equals to f cos of 60 is equals to t cos of 30, and f sine plus t sine is equals to 5. T is equals to f cos of over cos of 30. If I'm not wrong, it is 30. It is 30. So using put in number. So you put this value in number 2. F sine of 60 plus f cos of 60 over cos of 30 into sine of 30 is equal to 5. F is common. Sine of 60 plus cos of 60 over cos of 30 multiplied by sine of 30 is equals to 5. So you can use calculator for this working. Sine 60 plus cos 60 multiplied by sine 30 divide cos of 30. This answer is coming as 2 root 3 upon 3 is equals to 5. So t is equals to 5 multiplied by 3 over 2 root 3 cross multiplication. And here is 5 multiplied by 3 divided by 2, and this answer is same as before. T, when you use calculator, 5 root 3 upon 2 newtons is the value of T. Use this value in, yes, you can use it here. You put this value in 3, the final answer would be there. So this is the value of not, sorry, this was F, and so this was F. So we have the value of F. F is equals to 5 root 3 over 2, and you can use this value in number 3. So multiply by cos 60 divided by cos of 30. Yes, this answer is coming as T is equal to 5 over 2 Newton, same as before. So this is the math. There are 3 methods for solving this question. And yes, this is the method. Thank you very much.